Yeah. So I think some of the people have joined. Very excited to have Jordi with us today. We're excited to have this online event for the Taipei Ethereum Meetup group. So Cici has helped me set up the video conferencing. Is everything checked? Okay, cool. Yeah, so I'm excited to introduce Jordi, the speaker of today's event. He's the founder and technical lead of Hermez Network. He's the founder of Ident3. He's also the creator of Circom, the zero knowledge circuit programming language. Yeah, so please welcome.
Thank you very much. It's a pleasure to be here.
Yeah. Do you have?
I have a presentation if you want, but if you want to do any other format like more query and answer, just let me know. I'm a little bit prepared for everything. I'm flexible.
If you have slides, it would be cool.
Yeah, I can. Let me share a little bit the slides. Share. Let me stop some. Okay. Well, but let's start. I just want to talk about layer 2 rollups and a little bit how it works. Especially Hermez is the one that we just put in production last week, and it's fully running in mainnet, so everybody can test it and try to explain a little bit how it works. Please interrupt me whenever you want. Just if you have questions or everything. As I told you, I'm quite flexible.
Yeah. Okay.
So rollups. Why rollups and why layer 2 solution? Well, the answer is very easy. Right now, gas cost of Ethereum are very expensive. Doing a transaction in Ethereum, depending on the time of the day, but it can cost, normal transaction can cost you more than $10 or $20 just as a regular transaction. If it's a token, even more, and if it's some smart contract like Uniswap or something like that, can cost you really a lot of money. Why that happened? Well, that happened is because the number of transactions that Ethereum can do is limited. Actually, the limit is the gas limit, but the gas limit. So each transaction consumes some gas. So at the end, is the number of transactions are limited in Ethereum, and I would say it's limited in any decentralized blockchain. Of course, if you centralize things, then you can scale faster. But if you really want to keep the network decentralized, then all the blockchains, they have their own limit. Bitcoin, for example, is around 3 transactions per second or something like that. Ethereum is maybe 10 times more, 30 per second, but it's still limited. And when this capacity is fulfilled, then it's a matter of whoever pays more. The one that whoever is willing to pay more is the one that has priority. So then the gas cost, so the fee of the transactions increase a lot. And this is a limitation because these blockchains, when you really want to build a project that's not a test or it's not for a very small set of people, you want to bring, for example, cryptocurrencies to every person in the world, or even to every person in a country, or for a real project, then this becomes a problem. It becomes a huge problem. So we need to have something like that keeps the properties of a decentralized blockchain, and but that scale, that have a huge throughput. So with layer 2 solutions, we can increase that in 1 or 2 orders of magnitude easily. Okay, actually with the current blockchain. Okay, so here I put some numbers. For example, is with Rollup we can do around 2,000 transactions per second, full capacity, If we compare that with Visa, it's more or less what Visa is doing right now in a normal usage. They have a capacity of much more, but daily peak is 4,000 transactions per second. So here is very much layer 2. So rollups with the current state of the blockchain, with the current state of the art, it's possible to reach these numbers. And there is margin to grow and to have even improve these results much more, because it's a new technology and there is a lot of new things that can be done here. Okay. So more or less why this happens. Mainly what it does, the layer 2 solution like a rollup, what it does, it puts a lot of transactions. Let's say, for example, 2,000 transactions, and they pack them in a single Ethereum transaction. Okay, so at the end is if we can do, in this case, it's a huge transactions, but in this case, in each transaction we can pack around 2,000 transactions per batch, and we can put around 15 of those transactions per block, and this is where this around 2,000 transactions per second comes from. Of course, this would be Ethereum only doing this. Okay, so this is if you compare the 30 transactions per second with 2,000 transactions per second, this is 2 orders of magnitude more than what currently Ethereum can handle. Okay, so layer 2 solution, layer 2 mainly a rollup. What's a rollup? Well, a rollup is like another blockchain. Imagine a separate blockchain. In each blockchain, like any other blockchain, you have a database of accounts and balances. This account holds this balance. This account holds this balance. This account holds this balance. So we have a state, which is the summary of all the current accounts and of the current balances of the accounts that we have. Mainly, what we do is we Merkelize this in a state root. Okay. And then in each batch, so in each transaction that we are processing, actually we are taking many transactions. In this case, in the case of the picture is 3, but it can be up to 2,000 transactions, and we compute a new state. These transactions mainly is transfer one ether from this account to this account. This is the kind of transactions that we are processing. We process 2,000 transactions and we create a new state. And every time, in every batch, we process as much as 2,000 transactions per second. So we are keeping these on chain. Okay. And why this works? Okay, because if we put 2,000 transactions per second and we use, for example, a normal smart contract to process those transactions, this would cost much more than just doing the normal transactions in Ethereum. Why they can be packed? Why they can be rolled up? Why can they be summarized in a single transaction? Well, here is a new technology that's called zkSNARKs. Okay, especially, and the important part here for scalability is this S. This S stands for succinctness. What does it mean? It means that with this technology, we can have a deterministic program that maybe it can take a long time. It can take a long time to compute. Okay, imagine that it's a deterministic. So you put an input. Imagine that a program that computes, I don't know, 1 million hashes. Okay, this will take a lot of time. Okay, you put it in a computer, and maybe it takes like 1 day just computing that. Okay, and if I give you the result, and you want to check that this result is valid, what you would do? Well, in the normal cases, what you would do is just compute again this 1 million hashes. You just take this hash and you compute 1 million times, and then you see that, okay, that's correct. The result that you gave me is valid. Okay, but with this technology, the prover, so the first, I can compute these 1 million hashes. Of course, I do it, but besides computing these million hashes, I also compute a proof that this computation is valid. So I can give you the result of this computation, I can give you this proof, and you don't have to run again the full process for 1 day. You just verify this proof, which it takes milliseconds, and then you have the warranty that this computation is valid. Okay, so this is what's the snarks about. And the succinctness means that you can verify a computation much faster than just having to run the computation again. Okay, so this idea is took it in the rollup. So right now, the computation in the case of a rollup is the verification of these transactions. So in the rollup, we are taking the last state. We are computing and verifying all the transactions. We are verifying that all the signatures are valid, that each transaction have enough funds to be transferred from one side to the other. So on all these computations are computed by an operator, a coordinator. In this case, they compute this proof, which is expensive, computationally is expensive, but then anybody can take this proof and verify that this is valid. So here, when we are computing a batch, the operator is doing that. It's taking 2,000 transactions, is computing this, we call it circuit, this deterministic program. We are computing this zkSNARK, this proof that it's something that's this proves that these transactions are correct, that they have the valid signature, that they all that they have that the fees is that the balances are removed from each sender, are increased in each receiver, so that everything is valid. Okay,
Mhm.
so we compute this proof, and then we do and we send this proof to the blockchain. In this case, this is a smart contract, and the smart contract just verifies these proofs. And because this verification is very, very fast and it's very cheap in gas costs, in gas terms, it's much cheaper than just running the full process of verifying all these transactions. That's why we can pack all these transactions. And this is the basic. This is the basics of a layer 2 solution, of a rollup solution. It's not. This solves, I would say, most of the problem, because we are the trick here is that one operator computes this proof, which is expensive, but the remaining, in this case, is the blockchain, the smart contract, if you want, the Ethereum blockchain, just verifies that this proof is valid. But there is another part that's important for the rollups, and this is the data availability. The thing is that, okay, there is an attack. There is an attack here that an operator can just get their own transactions, but they don't publish those transactions. Then they can create a new state, which is a valid state. It's a valid state, but then nobody else knows how this state was generated, how this state was computed. And then the rollup would stop. So it's important that in some way, all the information that you need to build this state, if you want all the transactions that we are processing, they need to be available. They need to be available they need to be available somewhere. Okay, and here is where the difference between zk rollups and zk Validium. In the case of zk rollups, like Hermez, what we do is we store this information in the same blockchain. So in the transaction, actually in the transaction data, all these transactions, a summary of these transactions is included in each transaction. So all the information is on chain. There are other solutions like Validiums that what they do is they put this information maybe in a federated network of servers, or even somewhere else. Okay, yeah. But the cool thing of zk rollups is that they can put it on chain. Here, let me just mention, because there is another kind of rollups, that's optimistic rollups, that I just want to point out. The difference between a zk rollup and optimistic rollup is that optimistic rollup, they don't compute this proof. Okay, they just put the new state of the chain on chain. Okay, and they assume that's valid. And then they have a gaming system where the people can challenge, and they can challenge, and of course the operator need to put some collateral in there, and if the challenge goes wrong, then they lose the money, and there is this gaming system. That's why in general, optimistic rollups, they take a lot to finalize transactions, because you need to be sure that there has been no challenging system. So, and this may take maybe a week or even more. Okay.
We do
And
have
the cool,
features
yeah.
for optimistic rollups. I wonder
I'm look,
if you want to
I'm
get words for for the optimistic
I,
roll.
yeah, it's, I would say, I think it's better named pessimistic rollups actually, that optimistic rollups, because it's like, I'm not sure if I'm gonna, if I need to wait for a week.
Because Jordi just mentioned.
Oh, yeah. But I have a question.
Yeah.
Do you submit the zk proof with the batch together, or you submit separately?
We do it together. In the case of Hermez, we do it together. There are different techniques to doing that. In the case of Hermez, we do it together. So it's just a single transaction that have all the information. If you want, I can try to. You can see my screen, right?
Yes. Yes.
Yes.
I can show you, for example, here is the. Can show you, for example, a normal transaction of this. Okay, see, this is a forge batch. Okay, here you have this is the proof more or less, and here we have transactions. Here in this batch there is no many transactions, but here you can see all the transactions. And this is, well, this is a normal batch. It's in Brinkley. We can see it also in mainnet. I do not, well, maybe I can have if I scan. If you go to Hermez Network. Here is the mainnet, and this is see here, for example. Let's see if this transaction is but this is an L1 transaction. Let's see if we can see it. Let's see if this is one of those force batch. Okay, so this is the mainnet, but you see that more or less is this. Okay, and here is the lot of transactions. Well, here is not many transactions yet, but here is, you can see all the data availability is also in here.
So once they are published, they are finalized instantly.
Exactly. Once it's mined, once it's included in a block in Ethereum, you know that this state is valid. It's okay. You cannot revert. It's you don't need to wait, and you don't need to have this collateral. So this is. For me, this is the nice thing of zk of zk Rollups, that this adding this proof. Of course, it's a little bit computationally costly, but it adds a lot of value. It solves many of the difficulties, because all these optimistic rollup, when you start thinking about all the things that can go wrong, and all the edge. All the vector attacks, just send somebody that wants to do a huge transfer, and then is trying to buy the operators, and it's there is some just a coordination between operators and transaction senders. It's like a lot of gaming there. Okay, I'm not saying that the optimistic rollups will not work. I'm not an expert. I have not been like deep in the optimistic rollup, but my feeling is that having zk rollups, it makes no sense to go to optimistic if you can do it. If you can do it with a zk rollup. ZKs, the problem with ZKs is that it's more difficult, for example, to do smart contracts and other things that you want to extend other things, and that's why optimistic rollups maybe are in advantage here in usability, because they don't need to build this proof, and so they have this advantage. But if you are able to build the proof, then it's much better. So it's but just an opinion. It's if you talk with other people in the community, well, of course there is very important groups that are working in optimistic rollup, and who knows, it's like we'll see.
Yeah, I think that makes sense and pretty cool. I'll let you continue.
Yeah, well, I can. It's well, here we talk about the data availability, and more or less, I think this is the most important thing about the rollups. Things that I wanted to mention is that Hermez is a decentralized system. That means that because we see that in the rollups, we need this person that's the coordinator, the one that's building the proofs. Okay, so in most of the rollups, this coordinator is centralized. It's just a single person or a single entity that's just running this coordinator, and that's it. Okay, so this breaks a little bit the rules of decentralization because we are building the centralized system. So in the case of Hermez, anybody can be a coordinator. Okay, how it works? Well, the idea is that there is an auction where there is an auction. This auction is done in a smart contract on chain, and the idea is that you can bid for slots. Okay, each slot is 40 blocks, which is 10 minutes, and during those 10 minutes, you can forge as many batches as you can. If you can forge 10 batches with 2,000 transactions each, you will get all the fees for that. So actually what you are doing is you are bidding, you are buying in some way these slots. Okay, so and anybody can buy it. It's an open protocol. Anybody can buy those slots. Okay, so this is the way. This is the mechanism. We call this a proof of donation. Why? Because of all the Hermez tokens that are collected from the bidding, part of it is burned, part of it it's reimbursed to the users of the community, and so 30% is burned, 30% is reimbursed to the community, and 30% goes to the layer one, to layer one, to Ethereum mainly, because rollups, they are layer 2 solutions and they are built on layer 1. And it's important to understand that we need very good layer 1 blockchains in order to run even better layer 2 solutions. So it's important that there is this payback to the layer 1 solutions. And this is why Hermez includes this mechanism in the protocol just from the day zero. And this is very much the, I would say, the main things. There are some details, of course, here that are interesting. For example, we can talk about the on-chain transactions. So the thing, one of the attacks here, for example, is that you send an L2 transaction, and the coordinator just don't forge that transaction. Just forgets about that transaction, and your money, your tokens are stuck inside the smart contract. Okay, so this they could censor in some way. So how we solve this censorship? How we convert this in censorship resistant? Well, the way we do it in Hermez is that you can always do what we call a layer 1 transaction. So we can send a transaction in layer 1. Of course, you will have to pay the gas, but then the operator in the coordinator in the next batch will be forced to include that transaction. These L1 transactions can be to create accounts in the Rollup, so to deposit accounts, to exit, so to withdraw accounts, and to force exits or to force transfers. Is the kind of transactions you can do. Another interesting thing in Hermez Rollup is that, for example, you don't need to, so a new user do not have to, they don't need to have Ether and create a new account in the, they don't need to do any layer 1 transactions to start using an account in L2. They just create the account, and then anybody can send money to them. And it's the coordinator who actually does this creation process inside the rollup. Actually, is do this creation. So this is very interesting because for new users, I expect that it's going to be people that they will never hold tokens in layer 1. They will just withdraw funds from an exchange in layer 2. They will use those. They will use those tokens in the layer 2, and when they want to convert it back or just convert to other tokens, they will send to the exchange in the layer 2. So that's a cool thing of this rollup. You don't need layer 1 you can deposit and exit to layer 1 if you want, but
Right.
I expect that most of the people in the future, they will just use just normal layer 2s. We have also another interesting concept is atomic transactions. Atomic transactions actually allows you to send two transactions to the system that they must be forged together, and this is very cool. For example, for doing kind of decentralized exchange. The idea is that, okay, I send you rapid Bitcoins in exchange of Ethereum. So I do a transfer of Bitcoins from Ethereum from account A to account B, and a transfer of Ethereum from account B to A. And those two transactions are linked in a way that either both are forged or none are forged. And this is already included in the current protocol. So this will allow to do some interesting things with decentralized, just connecting with decentralized exchange and so on. We also have another concept that's interesting. Is one thing, it's called massive migrations. This is a way of transferring, massively transferring from one layer 2 solution to another layer 2 solution with a single layer 1 transfer. Okay, and this is already possible with the current implementation of Rollup. And many things that can be built on top of that. Instant payments is one of the things that we want to build very soon, and it's like a lot of things to do. And I want to stop here because I don't know if there are many questions. If not, I can talk whatever you want. But I think it's interesting if there is questions about Hermez or about anything.
Anton is from Open, the DeFi protocol. Anton, you want to ask a few questions?
Yeah, I actually have a question. So the coordinator role you described, is this something similar to how sequencer work in optimistic rollup? That they can provide you instant finality and then later submit the proof?
You could no, it's not exact. It's more than that. It's we use them in a zkRollup. You don't actually you don't need as much, at least, sequencer, because the transactions are final very fast. It's at the moment that they are forged in the block, that they are final. So here the rollup coordinators, they work very much like a miner in a normal blockchain. They just choose the transactions that are in the pool and they just include there, and they do not. So there is no consensus. So there is no consensus of which transactions are included and which not. Just the coordinator just take the transactions and they put there. Very much like a normal miner, they take the transactions of the pool and they include them in the block. And this is possible because there is no delay, or the delay is very small compared with an optimistic rollup. In a normal actually, for example, right now in Hermez, we are forging one block every 10 minutes, at least. If there is more transactions, this can be increased, maybe one block every one forge every block, okay, which is every 15 seconds, sorry. And right now, computing a proof, a huge proof, a proof of 2,000 transactions, it takes about 1 minute or even less. So we say that right now, it's possible to achieve a finality of 1 minute. Right now, maybe it's 11 minutes, okay? But it's like the Bitcoin finality. It's like we are around the Bitcoin finality. So this is not required. The problem is when you have a week and you need finality, then is when you start needing these sequencers and other more complex things for that. You can run sequencers in zkRollups for going more to instant payments. If it's not enough, maybe to wait 10 minutes and you want to have instant finality, then you can do the same tricks. And this is what's about this. If you want, and we call it layer 3, okay? That you can run on top of rollup of a zkRollup and things. But no, zkRollups are more simple. The nature is much more simple. Just pool of transactions. You are getting the transactions. Coordinator just put it in the block, and that's it.
So it's similar to I can imagine all the L2 nodes as kind of like a different network, and then I'll only be interacting with that network, but I can look at those transactions on maybe a different explorer, right? But I will also only consider it like final when it's forged on L1.
Yeah, it's like they need to be included in L. So in order to be final, they need to be included in L1. So the batch must be forged. So the coordinator needs to send this transaction to L1, and the moment that this is mined, then the transaction is final. Here is,
Okay.
let me show you, for example, go to Explorer. Well, this is a testnet, but let me just go to mainnet. Okay, this is, for example, the last batch here. There were 2 transactions. You can go here.
Jordi, can you share the screen?
Oh, yeah, yes. Yeah, sorry, yeah. I just, moment. It's a batch explorer, okay? So you can go to a specific, specific batch, okay? And you can see these transactions. You can go to the transactions, you see the transaction. So it's very much like a normal, like another blockchain. You have all the transactions, you have balances, the counts, or everything that you have in a blockchain. In this case, you can have multi tokens, so an account can have many tokens, and yeah, you can see that.
Okay.
Do you have questions from
yeah.
the
Oh,
Ethereum Foundation applied ZKP team? CC.
Yeah, I have a question about mass migration. So
Yep.
You now have the mass migration from L2 to L1. Do you have mass migration from Hermez to other rollups implemented?
We have the part of the, we have what's required from the source part. So let me just, okay, let me share again.
Yeah, sure.
Yeah, I'm just. Is this? You see here the mass migration here. So here is when mass migration has 2 parts. You know, the source rollup, the one that's sending massively tokens to the destination rollup. Okay, so we have everything that's required to do a migration to another rollup in the Hermez side, as Hermez as a sender. It's said in other words, if there is if there is another rollup that wants to receive funds from Hermez, right now it's possible. They will have to implement something specific, but they will be able to do these massive migrations.
Do you have the contract interface or?
It's a contract interface. Yes, the way to do it. I have another presentation. I have a full presentation.
Oh.
About massive migrations. Let me see if I find it. Massive migrations. Okay.
Nice.
Well, here is the idea is that the main idea is that the destination rollup has an account, can create an account in the Hermez rollup.
Okay.
So the idea is that, and then you have on chain, you have all the information, so you can extract all the information of all the transfers that this account received. Okay, so this contract actually what it does a normal this is for setting the account. So a smart contract can have, the cool thing is that a smart contract can have an account inside the Hermez Rollup. Okay, so this is how to do it. Okay, and it does the withdraw, and finally it does the migrate. Okay, then the migrate, what it takes this information, so it takes the information of the transfers that they received, that this account received. It gets the funds, and then it redistributes. It needs to process all this redistribution, and this can be done like as a rollup. It can be done with a circuit and changing the state, the same way that we are changing the state from A to B. So these state transition functions, instead of processing normal transfers, okay, the destination rollup, they can have a state transition function, this circuit that actually what it does, it processes imports. It processes these massive migrations. Okay. This is this information here you see in red. L2 transactions is one batch. Okay, so here, well, if you see here, actually is here you see you get the L1 L2 data hash map of the ID of a specific batch. Okay, so this is a hash of all the transactions of a specific batch on the source rollup. Okay, so it takes all this hash, which actually includes all the transactions. Okay, and process a circuit. In this case, is an import circuit. Okay, which takes each of these transfers that they were made to this smart contract account in the layer 1 transaction, and actually process. So from the current state to a new state. So actually, it says who these tokens belongs to, because there is only one layer 1 transaction that includes the aggregation of all the tokens of many layer 2 transactions, and here you just redistribute it back. You send them back to each individual. Maybe you link it by Ethereum address, or you link it by whatever, signature, or whatever you want to process. Okay, but the interesting thing is that you can take this. So this for each batch, you have this information compressed in a hash, but we have all this information, so we can process that. You need together with in the state root also, because the state root is included by maybe the source, so who's sending the Ethereum address, or the important information that you need to link the funds in the layer 1 and in the layer 2. Okay, but all this information is there, and in the case of Hermez, this is done. This is doable. You can start importing massively transactions from the layer 1, but you need to build, if you want, the destination rollup. So this destination rollup you need to actually build. Here I do this presentation, I do some tricks how to build this destination rollup. We are working on that, and I hope we can have some full demo, maybe running in testnet for transferring, having a rollup that's like another Hermez, or Hermez 2 if you want, and then doing this massive migration.
That's
okay.
Cool.
This is more it's something, it's future work, but the cool thing is that Hermez is prepared for these massive migrations.
I see.
Any other questions from Martinen, maybe?
Yeah. So actually, I got a couple questions. I would say it's more maybe on the business side. So I noticed that you selected like USDT instead of USDC as one of the tokens as a starting one. And so just wondering on the thought there, like why did the network choose USDT instead of USDC?
No. We are using any ERC20 tokens right now. The the current, so in mainnet right now, we support USDT, USDC, DAI, Rapid Bitcoin, Ethereum, and Hermez tokens. We will add more tokens during this week, maybe today if I have time. But the idea is that the smart contract will allow very soon that anybody can add the ERC20 that they want. So it should be open, it should be decentralized. Right now we are controlling because we are some way, we just launched it last week and we are just monitoring very much the chain, and we have still some centralized pieces like this one. We are non-custodial, but we have this fine tuning, and this is one of the things that we are fine tuning. But the idea is that very soon anybody will be able to add any ERC20. But the network is token neutral. It can be any token can be used. USDT is it's an important partner in some way because well, they choose to use they choose to so USDT people they choose to use Hermez because they can save a lot of funds using Hermez, and it's very good for them. They are spending like, I don't know, like $20 million every month or some crazy amount of money, and you can save like 90% of the fees just using a network like Hermez. So it's good, and yeah, we are glad to have Tether that use the system, but it's not close to Tether. It's not the only. There is nothing special for Tether to use a network. You know, USDC they can use it if they want. DAI they can use it if they want. I don't know, any crazy token can use it. I would say that the token needs to have value because here in the Hermez network the fees are paid with the same token that you are using. So if you are using, I don't know, status token, and you will need to pay the fee with status token.
Mm-hmm.
And this is how it works. But besides that, you know, you can. It's not specific to any token.
Got it. Makes sense. So basically, it's a guarded launch, and right now, you said right now it's a whitelisting process, like for you to add it or not. Because I was referring to the blog post Hermez Network mainnet launch, and in that blog post, it was mentioned that only ETH, USDT, DAI, and WBTC and HEZ is available. But sounds like you already like expanded that, to others already, right?
Yeah, it's look what it is we have a parameter in the blockchain in the smart contract, which is the cost. It's the cost of adding a token. So for adding a token, you need to pay some HEZ tokens. The idea is that this cost to be zero or something close to zero. Mm-hmm. Okay. And right now the cost is, I don't know, it's infinite. It's more tokens that actually more tokens that Hermez there exist. Okay, so it's a way of saying that only us we can add. But the idea is to go fully decentralized. That means that the idea is to put this value to zero so that anybody can add a token, and the smart contract has a mechanism that even as we will not be able to change this value. This is when I'm saying that we want to go fully decentralized, meaning that we want to have so zero governance. So right now we have some parameters that are still fine-tunable. This is one of those, but the idea is to remove all these so that the governance that cannot touch anything. So the idea is that there's a fully decentralized protocol. Right now we are guaranteeing, we are doing the guarantee that the governance they cannot get the funds under any circumstance. So it's non-custodial right now. So this is done from the day zero. That's a matter of responsibility. And the idea is not only that, but that we cannot touch any of the parameters of the system. Other parameters are like, for example, the donation address. Okay, I think that right now is still 0x0 until we get an address from the foundation to get deposited. We are fine-tuning some of those parameters. There is a minimum price. Another thing for going decentralized is that the bidding the bidding mechanism that we make. It makes a lot of sense when there is a lot of transactions, but right now it's not profitable to forge batches. Now we are forging one batch every 10 minutes, so we are spending a lot of money just forging those batches, and most of the batches right now are, if not empty, close to empty, because we just started and there is very few integrations yet, and we just opened the store right now, and it's still very early days. But the idea is that we at some point reach a break even, and this break even, this means that it would be profitable to forge blocks, so that people will start betting, and then is when the real protocol will start becoming decentralized. So that's why it's important to now start having volume, to start having transactions, so that the protocol gets decentralized. This is all work right now. Integrating, having different applications to work with, at the end having volumes, even going to different countries and people start using it. There is any idea. So the idea is that with Hermez, the cost is 1/10 of the gas cost of Ethereum. So the idea is that we expect that there's going to be more demand in the upcoming weeks and months, and the idea is to reach this break-even situation even more, so that there starts being external coordinators to start forging blocks and start bidding on the slots, and all these parameters, just removing ourselves as governance and having a governance-less system, fully decentralized. This is the goal for whatever, as soon as possible. Maybe it's a year. Okay, what's a year?
Yeah, kind of follow-up question, since you mentioned incentive. In the middle, you're saying that the incentives are paid out with the token that is sending or transacting, right? And so I was
the fees, yeah.
So there are two things here. One is I was wondering whether this is a fixed fee, for example, fixed in USD terms, or is it a percentage-wise fee? And so that's the first question. And then kind of follow-up and related question would be, if it's a fixed one, what kind of oracle? I assume you need some sort of oracle to kind of keep track of it, right? And so what kind of oracle systems are you using here?
Yeah, here is the most important thing here is that the coordinator is free to choose the policy they want. Okay, they can say, okay, I'm just for example, saying, okay, I'm the coordinator, and I'm going to include only the transactions that at least are $1 worth, according to this according to this exchange price, this exchange table. But this is a specific coordinator can set a policy, but another coordinator can have another policy. At the end, coordinators are like miners. They have a pool of transactions. Each transaction, of course, paying the fees in different tokens, and they are free to choose which transactions they include or not in the batch. And so each coordinator can set up their own policy. If we talk about policies, it's different. For example, policies where the network goes in full capacity, or when the network does not go in full capacity. When you are not in full capacity, so you have like right now that you have many slots that are free, then in general the easiest policy is to set up a minimum price. And the easiest way to say is, okay, let's set up this minimum price in dollars. Okay, this is a way of setting. Yeah, you can set up this minimum price in Bitcoins or in Ethers if you want, but just you set up a minimum at the end, a minimum worthy price. This is a good way. When the network goes to full capacity, then all the things change. In general, is okay. Then the coordinators have the incentive to include the transactions that have more fees, like Ethereum right now. Ethereum right now, in layer 1 Ethereum, they're running at full capacity. So who pays more, it's included. That's how it works. So here it's not very different than that. The thing is that here, instead of miners, we have coordinators, and the coordinators are free to choose which fee policy they want to include. Okay.
Yeah, makes sense. And so what I'm thinking is, typically people or miner, when they first started, they probably wouldn't have like much sophisticated policies, right? They will just like run the default one that you provide. I'm checking the GitHub right now. So right now there's this Hermez node. I'm assuming this is kind of like the Geth,
Yeah,
right?
pretty much.
Yeah. By default, then, like, what kind of oracle do you use there?
Well, here what we are just getting the prices. I think we are getting but this is the coordinator. Actually, the boot coordinator is getting the prices from CoinGecko. They are published so that we are publishing a policy. In this case, that the policy is okay. The transactions needs to be $1 worthy in fees according to these prices that actually we are getting them from CoinGecko. Well, this is just a specific policy, but this is a policy of a specific coordinator. Other coordinators can have other policies.
Got it. Makes sense. Thanks, Al.
Any questions from Vivian and Ting Han, and Kevin Mai Shen?有吗？有问题吗？ Okay, because I asked them because they used to work for. Well, they some of them are still working with Barry Whitehead.
Okay.
Yeah, and some of them are still working very closely with the Ethereum Foundation research team. And yeah, any other questions? I'll just wait for a minute.
Actually, let me follow up on the CoinGecko one.
Go ahead.
So for CoinGecko, I think I have experienced a couple of hiccups with regards to their price fee before. So is that the reason that you have a kind of a guarded launch right now? Because like CoinGecko, I think by default they uses the Uniswap pair, and they only use the ETH pair if possible. And so there are some special coins, kind of a reminder, if like in case you're not aware, like there are some special coins which are not paired to ETH, and oftentimes they have issues with those kind of pairs, right? And you might get a very volatile and incorrect price feed that is easy to arb. But of course, right now it's just starting the network, right? So like one of the things I look, so myself, I'm an auditor, right? And so I'm looking at how to mess up this thing in all possible ways, and like Oracle will be like one of it. And like CoinGecko is not as reliable. Like as I mentioned, like for special cases that is not pairing with ETH, that's one thing. There are sometimes how should I put it, like token updating or
yeah. Just taking CoinGecko just as an example. Actually, I think currently the implementation, the current implementation for each token, but this is something that's specific to each operator, right? That's what I'm saying. So, and in some way, each operator is free to choose whichever oracle they want. Actually, in the current implementation, you can choose to have a fixed price. For example, if you have a stable coin, maybe you just take, okay, one DAI is $1, and I don't care the whatever. You can decide this policy. I consider me as a one DAI $1. So if you are sending DAIs, so you will have to pay at least one DAI as a fee. I don't care if the DAI is 0.96 or 1.04. Okay,
Right.
so it's you can, so the operator can decide which price they want. They can have a fixed price. They can have they can get it from CoinGecko Oracle. I think we have implemented also from I think it's a Phoenix, but it's like you can implement as any other oracles. Even you can have a, I don't know, an average or a median of many others. So it's like this is very extensible, and this is, but this is only, just to be clear, this is only for defining a policy of a minimum fee in the case that you want a minimum fee policy. Okay, so you can have a policy that's I don't know, it's like, okay, I'm gonna forge all the transactions that I have as far as they have enough value, as far as there is value, a minimum value is not, and then I can get the values from everywhere else, and I don't tell even to anybody. I collect all the transactions. If they have value, which is that I include them. But it's another kind of policy that I can put in there. But this is something that's specific to the operator, and each operator will choose which they will set up the price. It's like when you are an operator, you are buying a slot, and then you are like God, like you are like a miner during that slot. So during that slot, you can do what you want. If you want to decide not to forge transactions, then you can do it. Maybe you will lose a lot of money because you have to bid for that, but you are free to do that. The same way that a miner is free to do what they want with their block.
Mm-hmm. Yeah, that totally makes sense. But you seem to stress a lot on the freedom that the like the node operator can choose, right? The policy. And so I am trying to dig that right now from the code. I'm not seeing the I couldn't easily find like the configuration for that, as if I'm an operator right now, and I assume this is Hermez node, and I clone it, I want to run it, and if I want to like customize my policy, do you know on top of your head like which how do I do that? If not, I can just like dig it.
It's in the configuration file. In the configuration file, you have different parameters there, but you can define there a minimum fee, maximum fee. You can define all these prices, all this Oracle system, where do you get the prices from? Okay, it's what you say. You can put it there, and you can also manage how many. Other things is how many. So how many? When do you forge a batch? Here is a more complex thing. Is when it's worth it to forge a batch. So here the idea is always this compromise between, do I wait for having more transactions before I start building the batch, or it's better to build the batch now with the transactions that I have, and maybe building another later on. And here it's going to be running operators. It's going to be fun. It's not an easy. It's not going to be an easy job, especially when we are talking about thousands of transactions. Okay, because it's like Rollup's idea is to scale. We are talking multiplying by 10 or by 100 the number of transactions that we are having right now. So this also means multiplying by a lot the fees, multiplying by a lot the database, that the space of database that you need, the transaction selector, all the optimizations on the transaction, selecting what are the right transactions. It's going to be I would say it's going to be a full science. We are starting right now. If you check the coordinator code, I would say it's a very simple, just it works. It's a very simple idea, but there is a lot of work to do there for optimization, especially when a lot of transactions start being in the system.
Yep, makes sense. I just found the Oracle part, so it's in price
Yeah,
data.
and you can see that you can add.
Yeah.
You should see that you can add very easily another oracle, and you can you can personalize with different oracles, and it's just a code place. It's a place where kind of a templates that you can put whatever you require. And yeah, I expect that the coordinators, especially when they become decentralized, so that it's not going to be one single coordinator like now. It's going to be like many coordinators running and competing with each other. Then it's when these fine tuning and these optimizations and these oracles and even connecting these coordinators with different exchanges. It's very interesting. Yes, running a good coordinator, not optimal coordinator, when you have a lot of transactions, is going to be very interesting because here is a lot of science that can be created on top of that.
Susie has another question.
Yeah.
From
Can you send multiple tokens in one batch or only one token?
Yeah, no. In each batch, you can send in each batch. We right now you can send 64 different tokens at most.
At most, and the coordinator need to specify their own token receiver state.
Exactly. All the fees are collected in layer 2. So the coordinator, they need to specify which are their accounts, the layer 2 accounts that they want to receive each of the tokens that are used inside a block. So in the block, actually the limits of the block is currently the big block is 1,912 transactions. Yeah. Of which 256 can be layer 1 transactions, it's 32 levels. So that's 2 to the 32 possible accounts. This can be increased with new circuits up to 2 to the 48 number of accounts. And and 64 transactions, 64 different tokens per batch, which I think it's enough for most of the cases.
I see. You have multiple batches in each one block, and so that means a batch is the maximum number that one snark can verify, right?
Exactly.
I see. Okay. So
this number is interesting because this can be increased. At least I would say it can be doubled easily with the same curve without changing many things. This could be doubled very easily. And once we change the curve and we go to BLS 381 and so on, you can multiply that by 16 easily. Of course, you need to compute. The problem is that then you need computing power to build a proof, and this is probably the biggest one of the limitations that exists right now. But right now it takes less than a minute to build 1912 so 1,912 transactions. It takes less than a minute to build the proof with a huge server. That's a regular server.
You said the BLS 12381 is that used for a signature or is that for the SNARK protocol? Do you verify that?
Yeah, it's we verified. This is for the SNARK protocol, but the idea is that we are using for the accounts, for the Rollup accounts, we are using Baby Jab Corp, which is a Corp that's running. It's running inside the SNARK, and then we are using EDDSA signatures of these Baby Jab points, these Baby Jab accounts.
Oh, I see. That makes sense to me.
Inside the idea is that inside the state, actually, if you see what's going on inside the state of an account, well, you have inside the Rollup account, you have the the Ethereum account, you have the baby Jab account, all of them in the same state. It can be zero, one of those, okay, because you don't have internal accounts, or a smart contract account, for example, will not have a baby Jab account, so it can be zero each of those. We have the balance itself. We have the token, so it's that balance of that token, and the nonce, so that you can increase transactions. This is the state that we have for each leaf of the state. It has this.
Yeah, it's interesting to me because we in Hubble Optimistic Rollup, we have a separate account tree to store all the public keys, but it looks like Hermez, you store the public key inside the state.
Yeah. There are different approaches there. I'm not sure which is the best. We choose this one because I think this is very simple. You know, it just has one kind of account, and this is what it is. But yeah, you can always. It's arguable. It's like, I'm not saying that this is best and this is worse. You know, it's like we'll see. We'll see in the future what's the best way to store the state. But this works quite well.
Yeah, so most of the people are engineers and researchers in this call, and I wonder if they have follow-up questions. Where can they best reach you, or where can they go to ask those questions?
Yeah, we have a Discord channel, Hermez Discord. If you look for that, it's you can find it there.
Is that
also, if you are in, yeah, it's I don't know. I will send it to you right now. But just if you look for Hermez Discord, you should find it easily somewhere. Okay. And if you are very interested in the zero knowledge part, and you are you're working in Circom, or you're working in Snark.js on some of the tooling there, then I would recommend you go to the IDEN3 Telegram group. It's an interesting community there. There is about 250 persons there. It's very nice people there. So if you are really a technical dev, and you are working with Circom, working with Snark, you have dope sort of things, just go to this channel, ask anything you need about that there. It's a very nice community there that somebody will answer your questions there. So it's a very good place to have. We also, I don't know, just that Twitter, just we are very much in Twitter. We do a lot of communications in Twitter. Yeah, that's mainly the communication channel. But so Discord is very easy.
Yeah. So I encourage everybody to join those channels. Any updates or any interesting things that we can expect in the next coming 2 months or 3 months?
There are, we just launched it last week. The next week we expect many projects, many exchanges just to join and to implement the Hermez protocol. We are working very close with them to just fine tune and working with all the APIs, and so that everything is ready. And I hope that in the upcoming days we can start announcing some applications and some exchanges that are compatible with Hermez. Another interesting, I would say it's not 100% related with Hermez, but at some point, yes, is that we are now preparing full rewrite. So Circom has been fully rewritten in Rust. There is a new version of Circom that we are just testing right now, and it's much better written with more professional people writing. And then I wrote Circom, and Circom was written in JavaScript. I think it's okay. It works. It's my baby, but. It's not. I'm not a compiler expert. So Circom has been fully rewritten with a team of that are experts in compilers. We have been working together for more than a year now. And I hope we can present this, we can open this project and we can present this project to the community in the upcoming weeks. We are testing right now, and this is going to be, I think it's going to be very important because this will, together Hermez with Circom. So Hermez is very important because in some way put Circom in a level that's production ready in some way.
Mm-hmm.
So when we join these two things together, I think it's going to be very important even for other projects that wants to build zk snarks based applications in a more mature way. Of course, all of this is open source, and yeah, it's normal. If you are in this space, you have to do things open source. It's no other options.
Yes.
Okay.
So thanks very much for your time, and thanks very much for your sharing. Yeah, we'll be having a few more events this month, and I hope everybody can stay tuned and follow our meetup.com page, so Twitter, and we also have a Telegram group. So yeah, so I'll see you. Thanks very much.
Thank you very much. It's a pleasure and very nice talk. Very nice talk with you.
Thank you,
Bye
Jordi.
bye.
Very
Bye bye.
exciting.
See you.
Thanks, Jordi.
See you. Bye.